Here we have the set A that contains the numbers 1, 2, and 3, and the set B, which contains the numbers 4, 5, 6, and 7. And now let's suppose that we're given a relation f from A to B, given by the set of ordered pairs f, which equals 1, 4, 2, 5, and 3, 6. Now we could ask, is this relation a function? And so to tell that, we could look at the graph. This will be A, this will be B. Got 1, 2, 3, 4, 5, 6, and 7. And our graph has 1 related to 4, 2 related to 5, and 3 related to 6. And so you see that f passes the vertical line test. So f passes vertical line test. That tells us f is a function. F is a function. And also notice that f passes the horizontal line test. F passes the horizontal line test. That tells us that f is 1 to 1. Now we could ask, is f onto? And the answer is no. Remember that not everything in B gets hit. There is no number in A that f sends over to 7. Right? There's nothing up here with 7. Like if we were to draw a horizontal line along 7, there's nothing that comes up to that spot. There's no dot. There's no red dot along this horizontal line. So 7 does not get hit. So f is not onto. So f is a function, f is 1 to 1, but f is not onto. Now let's look at f inverse. F inverse is 4, 1, 5, 2, and 6, 3. And now the question is f inverse, is the inverse relation also a function? And now remember that the inverse relation, f inverse, is from B to A. And also remember that an inverse function, or that a function must use all of the domain. So B is the domain of f inverse. And not all of the domain gets used, right? The domain has 7 in it. And f inverse doesn't use all of the domain. So f inverse is not a function.